All right. So today we're going to talk about hyperparameters and how to optimize them for Sidequest. And first of all, we should maybe consider what are hyperparameters. So this is a basic model. You should know this by now. And what we have are different model parameters. You can see them here. They're called the weights and the biases of the model. Those are model parameters. But we also have hyperparameters. It's something like the learning rate. For momentum, you have parameters. Something you manually set at the beginning of training that makes up the structure of your model and affects your learning. That's why they are very important. They are not learned, they are set by yourself. So they cause some effect to your model architecture, to your structure. And they also bring in some bias. Bias is it's a funny concept because, for example, in data ethics, bias is considered as some negative impact. In general, bias is rather connotated with something negative. In data science, some even call it the gist of learning, but you should always be aware of your biases. You should know what parts your system puts emphasis on and which it puts less emphasis on, and what effect this has. Yes, so let's remember what we try to do. We want to find, this might be a little confusing. This is a loss surface, and we want to find the set of model parameters, not hyperparameters, model parameters. Want to learn the set of model parameters in order to minimize the loss. In other words, to find the minima, which is here, of the loss function. Yes, and hyperparameters are set manually. That's why they're really important it's really important to think about them, to know what to do. They can fuck up your learning, to be a little bit more blunt here. All right, so what are we going to talk about? We're going to talk about manual optimization, random search, grid search, automated hyperparameter tuning, and yeah, you can read yourselves. We're only going to touch broadly about on these because it's going to be a later video. I'm going to give you further resources if you want to think about this. First of all, manual optimization. Easiest thing to explain, hardest thing to do. It's bringing your own knowledge into the hyperparameter optimization. For example, you have in your model, you really want to consider old trajectories. So you want to keep a lot of momentum. And then you set the hyperparameter for momentum, you set it higher. This can be one example. Or you want to have a really, really small learning rate for some specific reason. It's having insight and bringing that into your model. It's always, even though you choose any other of these things, it's always very important to know what your hyperparameters are and know what they do. Because later on in training, if you just implemented some stuff that helps you, it can really disturb you. Okay, next one, random search. Random search is also fairly straightforward. You have your set of hyperparameters and you just put random values in, run the model. Afterwards, you have an accuracy of the model or your loss, and then you compare the performances of different random values for hyperparameters. This can help definitely, but it takes a lot of computation because if you think about it, bigger models take days for training. You can not just randomly put hyperparameters inside them, but for you, this might for other smaller toy problems, this is definitely applicable. A little bit more sophisticated than random search is grid search. Grid search is where you have different different values for your hyperparameters. For example, you have 4 hyperparameters, and for the first one, you take 2 different values. For the second one, 4, 5, and again 2, or your 5 different values for all of them, and then you iterate over all different combinations of these hyperparameters. So for example, you have 4 hyperparameters. For the first one you take 2, then 5, then 5, then 5. That means you now have 2 times 5 times 5 times 5 different combinations your model will be tested on. Again, always same procedure. You have the values for the hyperparameters, you run your model, you evaluate the performance, and you compare it to the others in your grid. This is definitely a little bit more informed than random search. It's not that random as well. Still takes a lot of computation. Sometimes random search is applied first on a smaller with less values, and then you use these informations to apply them to grid search. Yeah, for both of them to not overfit, it is advised to use cross-validation, which basically means you have your whole data set, you cut your data set into n different partitions, and then you use n-1 partitions. So I have my data set, I have now 8 parts of my data set, I use 7 of these parts to train, and the 8th one I use to basically same as the test data set. So it's like a prior testing step, and at every iteration of the training I shuffle the 8 different partitions of my data set in order to not always have the same one as my testing data set, which is not the test data set, but like the test of your training data set, you can say so. Yes, all of these methods can be used and are definitely used, but we have more to them. We can also, if you think about it, machine learning, artificial intelligence is all about finding the right set of parameters to minimize some function. What we can also do is apply the same scheme to like find the optimal parameters for our hyperparameters. So we can get, you can say like a meta level. It's the basic idea of applying a neural network to your neural network, but they're like different ideas to do it, and it's all summarized under automated hyperparameter tuning. And for example, there's like Bayesian optimization. It's discussed a lot. If you're a frequentist, you're not going to like this one. What it's basically doing, it's using probability to find the minima of a given loss function. So you don't have to, and then it tries to like find the optimal set of hyperparameters for that loss function, so you don't constantly have to run through your whole model, but you have the surrogate function which you optimize your hyperparameters on. As I said, it's disputed, but it's used a lot. It's definitely used a lot, and there are like a lot of different implementations. Later on I'm going to show you some tools you can maybe use, a few different tools that I use that make it relatively easy to implement that. Further on we have genetic algorithms inspired by Darwin. You use survival of the fittest. So you have different networks with different sets of hyperparameters. You run them, you look at their performance, and you only take the best performing ones. And then you create, that's like the crazy part. That's, for example, what you do in PBT. You create offsprings of that. So you have, let's say, the 3 best performing models with the best performing hyperparameters, and then you create offspring with similar hyperparameters. You can also do that. It's also done a lot, and what we're also going to talk about, this is only here for I wouldn't say completeness, because there are like a lot of different methods, and I'm going to show you a little bit more in a paper that you can read, but they're also often task specific. But for kind of being exhaustive, I also mentioned multi-fidelity optimization. This is similar to Bayesian optimization, you can say. It's very complex. I'm just mentioning it here. There's a paper listed, and also a block that's a little bit easy to understand, that also goes on the background of Bayesian optimization, that helps you to understand that this is state of the art. It's used frequently and works very well by saving you some computation time, but it's harder to implement. Yes, but as promised, let's look at those are tools you can use to optimize your hyperparameters. That can help a lot, especially scikit-learn, I would say, is the most frequently used one. Yeah, but all of these help a lot. I will also link this page where you can find them, and further I will link this page on multifidelity optimization, specifically talking about hyperband and BOHB. Have fun reading them up. You won't need them for the TensorFlow course, but you will definitely touch upon them if you follow this path of programming, and the idea behind them is really magnificent. Yeah, and last but not least, there's a paper all on hyperparameter optimization. It's very recently, it's from 2021, even the end of 2021. And if you want to read up like on the specifics of some concepts, you can do that here. Yeah, thank you for looking at this Sidequest. I mean, it's not mandatory, and it will definitely help you. Have a lot of fun with the learning. And with that being said, bye bye.